In this video, we're going to look at some extra examples that use the multiplication principle. So example 1, 10 people are running a race. In how many different ways can the first, second, and third place prizes be awarded, assuming that you have no ties? So what do we need to do? We need to give away a first prize, then a second prize, and then a third prize. Okay, so I'm going to have 3 spots. So the first spot is going to represent first place, and then we're going to have second place, and then we're going to have third place. Now, how many options are there for first place? Well, there's 10 people running this race, so assuming any of them could win first place, we're going to have 10 options. What about second place? Can we allow repeats? So if we did allow repeats, what that would mean is that the same person could win multiple prizes. So could Bob win first place and second place? Well, that doesn't make sense because he can't be in 2 places at once. So if he gets first, then he finishes the race, and he can't then also get second place. So here you need to know that there's no repetition given the context of the question. Okay, so here we can't be whoever finished first can't get second, and the third place can't be anyone who got first or second. So we're going to have 10 times 9 times 8 ways to award these prizes. So that's 720 ways in total. Okay, let's try another one. Suppose 5 players of a hockey team are getting into a line for a picture. In how many different ways can they stand in this line? So each different arrangement of them is a different picture. Okay, but we're arranging all 5 of them. So we're going to have 5 spots, 1 for each player. Okay, so 1 spot for each player. Now, because there's 5 players to begin with, the first spot is going to have 5 options. Now, we can't have 1 person in 2 different spots, so the number of options is going to decrease each time I try to fill a spot. So I'm going to have 5 times 4 times 3 times 2, and the last one I only have 1 person left, so I only have 1 option for that spot. So this is going to be 120 different ways that they could take that picture. And if you already recognize this, you might see that this is 5 factorial, which we're going to talk about later. But if you do, it's easier to compute the number because your calculator has a button for this, generally. So let's try another one. So suppose you're going to order a sandwich. The deli that you go to has 5 types of bread, 3 different proteins, 2 types of cheese, and 10 different veggies. So how many sandwiches are possible if you must select exactly one type of bread, protein, cheese, and veggie? So here we have 4 different choices that we have to make. So that is going to be our 4 spots. So think about if you were actually doing this. You would go up to the counter and they would say, you tell them you want a sandwich, and they're going to ask you, what type of bread do you want? So then you're going to answer that. So that's the first thing that you need to do. So we're going to have a spot for which type of bread. And then after you do that, they're going to ask you what type of protein, and then they're going to ask you what type of cheese, and then they're going to ask you which veggie you want. And you're only allowed to pick 1 of each thing. So when they ask you how many different, what bread that you'd like, there's 5 different types of bread. So you have 5 different ways that you could answer that. So you're going to have 5 options for bread. The protein, there's 3 different types of protein. Okay, so we have 3 different ways we could answer that question. There's 2 types of cheese. Okay, so you pick one or the other, so you have 2 options there. And there's 10 different veggies, and you have to pick 1, so you're going to have 10 options for that. If you multiply these together, you're going to see that there's 300 different sandwiches you could make under these conditions. Okay, now slightly different. how many different sandwiches are possible if you have to pick a bread and a protein, but you don't need to have cheese and or veggie. So maybe you want your sandwich to just be bread and some sort of meat or protein option. So you don't need to pick a cheese or a veggie. But you might. Okay, so you could have a cheese and or you could have a veggie. So you might have a sandwich that has bread, protein, and cheese, no veggie. Okay, that would also be a type of sandwich in this category. Or you could have bread, protein, and a veggie. Okay, or you could have bread, protein, a cheese, and a veggie. So we should expect part B number to be bigger than the part A number, because all of the sandwiches that we made in part A are actually included in part B as different sandwiches that would be allowable here. So it's kind of nice to compare sometimes so that you can see, oh, that makes sense. Yeah, this number should be bigger, or this number should be smaller, or it can help you realize if you made a mistake. So, how many different choices do we have? We need to use multiplication principle here. So what if we try to do the same? So we have a bread, a protein, a cheese, and a veggie. Again, because we could technically pick all of these things. Okay, now, when we make our bread selection, we have to pick a bread. So we have 5 options. When we pick a protein, again, we have to pick a protein. So we're going to have 3 options, like we did above. Now for cheese, what are our options? We could have cheese 1 or cheese 2, because we're allowed to pick one of the 2 cheeses, or we could pick none. So would it make sense just to, instead of have 2 options here, we have 3. So I wrote it as 2 plus 1, just so I can emphasize here. This extra one, so okay, these are the cheeses. So there's 2 options to pick a cheese, and there's 1 extra option to pick none. So you might have no cheese. So I'm going to end up with 3 options there. So we can do the veggies in the same way. So if we pick a veggie, there's 10 options. But we have this extra option because we could say no veggie. Okay, so what we actually want to do here is 5 times 3 times 3 times 11. And if you do that, you get now 495 different sandwiches. And notice this number is in fact bigger than it was in part A. So that makes sense. So this is a nice little trick you can do if they just allow you to not pick something. You can just add in an extra choice saying, okay, I might not pick that. So that's a trick you can use. Okay, let's try another example. So on your bookshelf, you want to arrange 4 different novels, and 5 different biographies. So how many ways can you arrange all these books on your shelf? So let's just notice here there's 9 books total. Okay, now you want to put all of them on the shelf. So we're going to have 9 spots. 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are your spots. And now I want to know how many options are there for each spot. Well, I just mix all the books up, so I have 9 books total. So in my first spot, I'm going to have 9 books I could place. Now in my second spot, I can't place the book I already put in. Okay, so I'm going to be down to 8. And it's going to just keep decreasing like this until I use up all of the books. Okay, so if you multiply all that together, you should get 362,880. And again, if you notice, this is 9 factorial, which is a faster way to compute that number. But it's just the multiplication principle. So, how many different ways can we arrange all these books on the shelf so that the novels are together and to the left of the biographies? So, we're still going to have our 9 spots. 2, 3, 4, 5, 6, 7, 8, 9. But on the left, so the first 4 spots are going to be novels. And then the last 5 spots are going to be biographies. Okay, so we're grouping them. So we're going to have all the novels first, and then we're going to have all the biographies after. So now how many spots do I have for this first, the leftmost spot on my shelf? Well, it has to be a novel, and there's only 4 novels, so I only have 4 options. Now, the second spot, again, has to be a novel, and it can't be the one I already placed, so I'm down to 3. And then I'm going to have 2 for the next spot, and then my last novel has to go in the 4th leftmost spot. Now, in the 5th spot, I start using biographies. So I have 5 biographies left still, and I'm going to have to go down each time as well. So I'm going to have 5, 4, 3, 2, and then my last one. So if you compute this number, so it's 4 times 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. You're going to get 2,880 different ways. Now, one more of this type. Assuming all the books are different heights, in how many ways can they be arranged so that the books are in decreasing order by height, with the tallest on the left and the shortest on the right? So this one sounds complicated, but it's actually really not. So I'll do out my 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't really need to do this though, because how many options do I have for this first leftmost spot? Well, it has to be the tallest book. Okay, now because all the books are different heights, there's exactly one tallest book. So there's actually only one option here. Similarly, the second tallest book has to go in the next spot. Well, they're all different heights, so there is a second tallest. There's exactly one of them. Okay, again, if we go down to the end here, this is going to be the shortest book. And again, there is a shortest book. They're all different heights, so don't forget that. They're all different heights. So there's going to be exactly one. So every spot is determined by their heights. So here we're just multiplying 1 a bunch of times. There's only one way to arrange them here. The tallest one on the left, all the way down to the shortest one on the right. So don't let this confuse you. When this is like the arrangement is sort of determined here because of it depends on their heights. So this can happen sometimes. Now, example 5. So first we have a definition that you may or may not have heard of. So a palindrome is a number or a word that reads the same forwards as it does backwards. So for example, I have race car here. This happens to be my favorite one. This would be a 7-letter palindrome. So if you read it from left to right, it says race car. But if you read it from right to left, it still says race car. Okay, so an example of a number 1 would be, say, 1, 2, 1, 2, 1. Okay, so again, this is a 5-letter one, a 5-digit one, sorry. So if you go from left to right or from right to left, you get the same 5-digit number. So hopefully we have a handle on that. So now the question wants to know how many different 5-letter palindrome words are possible. Okay, so we're going to have 5 letters. So letter 1, 2, 3, 4, and 5. Now, we're doing letters here. Okay, so 5 letters. So there's 26 options, 26 different letters. So there's going to be 26 options for the first letter. Now, what does that mean for the 5th letter? So if this word has to be the same from left to right as it is from right to left, the 5th letter has to be the same as the first letter. So once I pick the first letter, the 5th letter is determined. It has to be the same number, the same letter, sorry. Okay, now what about letter 2? You could have repeated letters, even though, so for example, A, B, A counts as a valid 5-letter palindrome. So we could have repeated the same letters we had in letter 1. So again, we have 26 options. But again, letter 4 has to be the same letter so that we read the same word from either side. So once we pick letter 2, letter 4 is determined. And now letter 3 can also be anything. So we're going to get 26 cubed, which is 17,576 different words. Different palindromes, 5-letter palindromes. Now, part B seems very similar, but it actually is a little bit harder. So how many different 5-digit palindromes are possible? So when the question says the word digit, what that means is, I'm going to put it on the side here. So the example I gave above is a good example of a 5-digit palindrome. But something like 02120 is not. Okay, so why not? It seems like it should be. So the problem is that we would actually consider this to be a 4-digit word, because the 0 at the front, we wouldn't actually keep that. So this is actually a 4-digit word, now not a palindrome. So you want to be careful that when it says 5, or when it says some number of digits, that means the first digit cannot be 0. Okay, so we're going to do something very similar. So we have our 5 spots. So this is number 1, number 2, number 3, number 4, and number 5. Okay, now this first one here cannot be 0. Okay, so we want to remember that. So normally we have 0, 1, 2, up until 9. Okay, so that's 10 numbers. Okay, so normally we have 10 options, but here we can't be 0, so we only have 9 options for this spot. Now once we pick the number in spot 1, we obviously have already picked spot 5, because it has to be the same. Now when we do digit 2, now we can be 0, so our number of options goes to 10, and we pick that. It means that spot 4 is already chosen. It has to be the same number. And then the middle spot can also have 10. So we're going to have 900 different 5-digit palindromes. So those are some examples using the multiplication principle. Hopefully it's starting to click.